everyone, and welcome to the next edition of Miton Times, both offline and online. Today it will be Radek Bartyzal talking about how to build a recommender system. Right, the floor is yours.
Thanks a lot. I hope everybody can hear me. Great. So yeah, basically this is going to be a quite information heavy talk because I've got like 2 minutes for each slide and they're not short. So I'll get right into it. Basically, this is going to be like an overview of what you need to do if you want to get from the state where you have no recommendation system and you want to build some recommendation system that will be, expandable and scalable up to, let's say, millions of items. This is like a basic overview of the talk. It's here mainly to show you that the actual act of like building models is going to take like less than 10%, even less of your time than all the other stuff that you need to do before you get to the state of having a functional recommender system, which is similar to any other, machine learning projects that you will encounter. So I'll start with some like basic architecture advice, and it's like important to realize that the recommendation system it's a living system. You should expect to always be tuning it, playing with it, adding some features, because almost any recommendation system is better than no recommendation system. So if you do this step, you start having some recommender system, it's probably going to bring you value, which means you will want to keep improving it to bring even more value. So I would, advise you to start with a simple code base. Don't necessarily optimize everything in the first time you're writing it. Just focus on having fast inference, because this is the only thing that matters for recommender system. You need to be able to actually recommend stuff quickly enough so your users on the website are not waiting too long, because then they will get bored and probably leave. And the general idea of the system should allow you to iterate as quickly as possible through this like very basic machine learning loop, that is getting data from some of your probably databases, other sources that you have your data stored in, training some models, evaluating these models, deploying them, and then monitoring them in a live environment. You will want to iterate through this as quickly as possible, because as we will see later on, recommender systems are kind of hard to evaluate, and you will most of the time want to do it in production. So you want to be able to quickly iterate. Now, some of the ideas that you might want to consider when designing the system, like what are going to be your next steps, most probably if you build a system, as I said, you start simple, you get into a basic like recommendation system that works. Then, you will probably want to keep adding more sources of data, like other types of interactions, like you will probably start with some clicks, but you will want to add other types, like maybe clicking on ads or users selecting some filters on the website, or you will want to start adding some features to your recommender system, like not just recommending items to users, but maybe recommending tags or even recommending users to items, all sorts of ideas that you will come up with, how to use personalization on your website. You will probably want to somehow integrate them into your system. And it's just another like example of why you should start with simple system, because you don't know in which avenue you're going to expand next. So you want to be able to quickly adapt with the system that you have. And if you start with something complicated, it's just going to be hard to do. Now I'll get to the basics of any machine learning model is your data. You need some data to be able to recommend anything. And the data is usually divided into two types. One of them is content information. It's information that describes the content on your website, like typically your items, whether it's, you know, some products or news articles or job postings, whatever, you know, it has some descriptions, probably some images, some tags, you know, some information about the content on your website. This is usually static. Then you have the interactions. These are more dynamic. These are interactions of users coming to your system, interacting with the content, you know, so clicking on it, ordering stuff, liking stuff, you know, things like that. So everyone has a little bit different types of interactions, but usually you have some types of interactions. If you're not tracking any interactions, you don't have to worry. You can just do with the content information. Even with this, you can build recommendation systems. It's definitely feasible. Now, what we're going to be talking about here, mostly it's going to be recommender systems at scale, which means that, you know, it's kind of expected that you are tracking some interactions that users are doing on your website. So it's expected that you will have both of these types of information. You know, you will have some content information and some interaction information from your users. Now, yeah, this is just a note to, you know, always choose your models based on the data that you have. Kind of makes sense. If you don't have a lot of data, if you don't have a lot of, you know, items, if you don't have this large scale, then you can just start with some like simple recommender systems. Like you can just, you know, start with bestsellers. Usually most eShops already have those. You know, you can start with showing users their last interactions, which is actually like quite nice. A lot of users appreciate it. Or you can get into some sort of like item similarity where you use the content information of the items. You basically you know, show users similar products, similar products to the products they clicked on and stuff like that. But even if you have this, you know, simple recommender system, it's not a system yet. It's just some model, and you still need to implement the whole loop that I talked about. You know, you still need to get some data for these simple models. You need to train them, you need to evaluate them, deploy them, and monitor them in production. Now, I'm going to be talking about these steps later on. Now, if you're getting into more like complex systems, it's good to start with a little bit of theory, and recommendation models are typically divided into two types. One of them is collaborative, and the other one is content-based. It's tied to the distinction of data that I talked about earlier. Collaborative models, they are based on interactions. So that means they are based on the users interacting with items. It's more dynamic. You can find some patterns in the data based on the users, how they interact with your website and the items on it. It usually performs better than purely content-based systems. These are the systems that use just content information, no interactions whatsoever, so that you don't need any information about what your users are doing. But the collaborative systems have some downsides. For example, the cold start problem, meaning if a new item comes to your site, doesn't have any interactions, you don't know who to recommend this item to, right? Because it doesn't have any interactions. So your model that uses only interactions doesn't know what to do with it. So in the end, you'll probably want to combine these two approaches and use all the information that you have available. So you're going to end up with some sort of hybrid model, both collaborative and content-based. Yeah, maybe.
What could be the features of users other than the user item interactions?
Well, you can also have like user interactions, not interactions, but users information about, I don't know, from their user profile or stuff like that. So that's similar to the content information, right? In a way that it doesn't change if the user, as the user behaves, you know, interacts with the website. But yeah, I think you refer to the content-based, right? Uses content features of users. Yeah. So content features of users can be their profile picture, for example. I don't know, but you know, I mean, mostly we are talking about the content information of items. Yeah. And yeah, so we're now getting to the like core of the recommendation system, like how to actually build the stuff that returns some recommendations if you have the data prepared. So typically when you want to build a recommendation system that's going to scale for up to, you know, millions of items, millions of users, stuff like that, it's going to be some pipeline of models. So you're going to want to start with some very fast ranker that ranks all the items on your website and, you know, kind of approximates the rank. How are these items interesting for, you know, a lot of times it's not personalized at all. It just ranks all the items. Now you use this rank to basically pre-select the items that you will pass to your slower, more, you know, intelligent, let's say, ranker that takes into account all the information that you have available, you know, the interactions, the content information. It's a slower model, it's more precise. And this model is like the typical recommendation model that you will read about if you Google, you know, how to build a recommendation model. You're going to find a lot of models, a lot of papers written about recommendation models. They're all talking about these like slower, better rankers. You know, these models are typically have inference times in like tens of milliseconds, which is where you typically want to be, because at the end, if you process the items by this better ranker, you usually want to have, it's not necessary, but you know, you will usually end up having some like next model that will re-rank the recommendation based on some like business rules, based on where on the website you're showing the recommendations, because on different places on the website you want to have a little bit different rules, right? So sometimes you want to have more diversity in some places, or in other places you want to rotate the items quicker. So you will have this like final tuning, final model that's that will adjust the recommendations a little bit. And why do we have this pipeline of models? It's the only reason is that we want to be fast. We want to be able to recommend to users, you know, relevant items, typically in around 200 milliseconds. So with the round trip time to your, you know, some cluster in the cloud, you get to 250 milliseconds, which is like a number I kind of made up, but I feel like it's a good trade-off between the user experience and the you know, the typical models and how much data they need, how much time they need. And right now, like our scale is, you know, 15 million items plus, and we are like confidently in a range of around 150 milliseconds, including the round trip time, you know, the 99th percentile of response times. I'm going to talk about the fast ranker now. The first that basically its job is to rank all the items as fast as possible. And it usually also uses some mix of interactions and content information, but you know, it can be as simple as calculating the conversion rate of each item and saying, hey, I'm going to sort these items by the conversion rate. Or you can use some smarter weighting of these parameters. For example, you can check out the Wilson score that I linked here, or you can use some XGBoost algorithms, like typically very fast, well-defined, already implemented tools that you just download, apply to your data, and they're going to return some rank that usually is quite okay. Or if you're more fancy, you know, you have more developers at your disposal, you can build some neural network, let's say, that's, you know, small, very fast, and takes into account all the information that you have, and it will also provide a similar role of ranking all the items very quickly. Now we're getting to the like actual recommendation model that takes these like tens of milliseconds to actually return some recommendations. Now, these models, like the way I like to think about them, there are several types of them, but like the most common one is some kind of latent factor model. What does it mean? It means that you just get embedding of an item, of each item in your database. You get embedding of each user, and then you basically, what you've done is that you've factorized the item user interaction matrix into a dot product of two smaller matrices represented by the item embeddings and user embeddings. So if you do a dot product between user embedding and item embedding, you get an approximation of the rank of this user item pair. You can basically, again, use already implemented tools for this. Like there is this implicit library for Python, for example, that does exactly this with matrix factorization. And you can also download any, other libraries that already exist. I definitely recommend to do that. Like when you're starting out, don't, re-implement some fancy algorithms, just use what's already out there, apply it, and focus on getting the pipeline right, focus on getting the whole loop of, iterating through the experiments as quickly as possible. So you will get to the state where you have a usable recommender system and you can start iterating on that and, playing with these models. The final, like domain specific tuning models, they are again usually very fast because their job is not to come up with these personalized recommendations. It's usually some tasks that maybe your marketing comes up with. Hey, we've got this campaign, we would like to boost these products because they're on like sale or something like that. So you take the recommendations that your previous model generated and you kind of boost the items that are on sales, or you want to boost upsell or cross sell, these sort of things. You can basically implement these models that will kind of shuffle or change the order of the recommendations a little bit to achieve some desired business goal, let's say. This was like for the recommendation pipeline, and now I'm going to talk about something that's a little bit offside. Basically, when you're building all these models, you have a choice of how to capture this issue with new data coming into your system all the time. Like when you have a live system, right? Users are coming to your website all the time. They're making interactions. New items are coming to your site all the time. So you either build a recommendation system that is able to incorporate all this new data basically at the moment that you get them in your database, or, and this is what I would recommend at the beginning, like start with something simpler, create a model that you just train once every couple of hours with the data that you have, and just retrain it every couple of hours and kind of ignore the fact that, hey, yeah, this recommendation system is not going to take into consideration the newest possible interaction on the website. But it's, it's going to be fine at the beginning. It's still going to be okay recommendation system, definitely better than having no recommendation system at all. Then as time goes on, you would probably like to incorporate this new information, and there are like models that make it easy for you. Like, for example, if you use the implicit library for matrix factorization, it has like already pre-implemented functions for exactly this. So you can just say, hey, yeah, recalculate this user with new interactions, and it's done. Or, you might want to use some other models that might make it a little bit more difficult for you to incorporate this information. You always have to watch out for the inference time so it doesn't get out of hand, because that's like very important not to have slow recommender. Because, if users have to wait a long time for recommendations, the recommendations, even if they're going to be perfect, they're not going to bring as much value as, slightly worse recommendations at twice the speed. So yeah, try to get it, under those 200 milliseconds. Another slightly, offside topic is testing. Basically, if you're implementing this machine learning pipelines and models and everything, I would recommend to get like some Sentry or similar service for logging the exceptions and sending notifications to your Slack or whatever you use for communication. Don't be afraid to use some continuous integration, but it's of course not necessary at the beginning. What I would say is necessary is implementing regression tests for all the models that you do, because whenever you will want to change the models, you will want to tune them, you will want to add new features, you know, optimize them, whatever. You want to be sure that you're not breaking your past functionality. So having some tests, it's definitely useful. On the other hand, I wouldn't advise you to, you know, have integration tests for everything at the beginning. I don't think it's completely necessary. Just get a very good development environment, ideally a cluster that's like a completely identical copy of the production cluster, test everything there. And, you know, that's mostly going to be fine in the beginning. Of course, as time goes on, you would want to, you know, get better at all these kind of tests and catching the errors as soon as possible, but it's not necessary at the beginning. At the beginning, you want to get to the deployment phase, you know, as fast as possible to see how the models behave in production. Now, before you deploy the models to production, though, you would want to evaluate them at least somehow, and that's called offline evaluation, meaning you take the data that you have, you just, you know, classic machine learning evaluation, you split your data into, you know, training and testing splits, and you just evaluate your data on that. This is like, in case of recommender systems, it's not as good as you might be used to from other areas of machine learning, because, you know, recommender systems are kind of special in the way that they change the behavior of the users, right? So if you deploy a recommender system that you evaluate it on your past data, and this recommender system was great at predicting, you know, what the users would click on, that necessarily doesn't mean it's going to perform well online, because when you deploy it online, you might show different items to these users, which you don't know whether they are going to click on or not. So it's always better to evaluate your models in online A/B tests. That's like the best way to see what the models actually bring. And I would recommend you to measure like really relevant metrics when you're doing online A/B tests, because it's, you know, it's simple to just measure click-through rate, the CTR of your recommendations, because you would say, hey, yeah, I'm showing recommendations. If users are clicking on them, then I guess, you know, my recommendations are good. Like 99% of the time, that's not what you want to do, because users click on like clickbait, you know, that's the definition of clickbait stuff. Typically some like naked ladies or something like that get a lot of clicks, but that's usually not what you want to show at the top of your catalog, what you want to, you know, show to the majority of users, even though it's getting a lot of clicks. So if you're doing A/B testing, be sure to define the metrics relevant for your business. You know, typically it's some kind of revenue for the business itself, at some like a little bit longer scale, let's say a couple of days at least, you know, even weeks in some cases. You don't want to make like very harsh decisions based on a small amount of data. Some proper statistical testing, of course, helps. I mean, every time. Now, if I get back to the offline way of evaluating the systems, there is like a simple way to do it. There are many different ways to do it, but one of them that I like is the leave last out evaluation. Basically, you take your users, you split the users into training set and test set, also validation set, and you take the users from, let's say, the test set, and you mask out their last interactions. You know, by last, I mean in time. So actually, like the most recent interactions you mask out, you give the other interactions to your trained model, and you let it predict the latest interactions of these users. And then you measure some classic metrics like recall, normalized discounted cumulative gain, or coverage. These metrics basically tell you how many different items you're recommending. That's the coverage. And recall is how many relevant items have you recommended to the user in the top like 100 items, let's say. And these metrics will roughly tell you how well are you predicting the relevant items for the given users. And these like offline evaluation metrics, they're good for, you know, comparing the models in a rough way, right? If you have very similar models that perform very close to each other, it's going to be pretty much impossible to distinguish them in these offline tests. Of course, one of them will always have better metrics than the other one, probably not all of them, but even that can happen. But even that still doesn't mean that it's going to perform better in online world, like in the actual A/B test. So I would definitely recommend to use these offline metrics for, let's say, maybe hyperparameter tuning, something where you have a lot of models, you need to cut them down into a couple of candidates and then evaluate those candidates in the A/B tests, even though some of the candidates might look worse in the offline testing. Now we're getting to the deployment phase. Basically, you've got your model, you've got the data, you trained the model, you evaluated it, so you made sure it's not like completely wrong. And now you want to deploy it. Basically, this could be another, like every slide could be another book. And so I'm just going to be quick about saying that, yeah, I mean, we use cloud. I think the cloud obviously has many benefits. And with these like recommendation systems, typical benefit is the automatic scaling, because like this plot is plot of our like number of requests in time across 14 countries. You can see that, you know, at night there are much less requests than during the day. Makes sense. Also, if you start some A/B test, you suddenly deploy like twice the amount of models than you had yesterday, so you suddenly need much more compute. And when you end the A/B test, you just don't need the compute again. So it's like the automatic scaling is able to save you quite a lot of money. And of course, like the whole cloud that allows you, you know, the managed Kubernetes and allows you to work with the provisioned hardware in a much simpler way than if you had actually like on-premise hardware. Now, so like simply, I would recommend to go for the cloud if you don't have already some infrastructure team that is taking care of your hardware and is able to support you in your needs, because, you know, you doing all by yourself, even in a, you know, some small to medium-sized team, it's going to be hard to manage your own hardware plus all these other requirements that are needed. And the last and one of the most important parts of the whole loop is monitoring. And that means that when you deploy stuff, you want to check how it's doing. You know, so one of the things are the A/B tests, of course, like you're measuring the actual added value of the recommendation system. But then you want to monitor how the system performs from several different angles. So one of them is the hardware health, you know, so you want to watch for the CPU and network throughput. And so if you're not getting slowdowns, not because of your model, but because of some network issues, that is like very common. And you want to check on your like auto scaling policies and stuff like that. Another view, like another angle that you can take when looking at the recommendation system is the performance from the website's point of view. So, you know, logs from the web's backend, basically telling you how many requests they send to the recommendation systems, if they got, you know, response for all of them, how long did it take, you know, measuring this time of response, including the round trip time, because that's actually important. Like even if your recommender system is very fast, if the round trip time takes too long, you're gonna have to do something with that. And of course, you wanna look at all the different statistics about your requests that you can to basically debug any issues that you might have with the performance. And the last kind of view that you might take is this like recommendation system performance from like inside of the system itself. So if you're rebuilding the models every couple of hours, as we said, with several of these models in the pipelines, you're probably going to be retraining them every couple of hours. You want this process, of course, to be automated. That's given, and so you want to be going through the loop automatically. You're getting the data, training the models, evaluating them, deploying them, and now in this monitoring phase, one of the monitoring that you want to have is watching these evaluation scores, let's say, of the models and some other statistics that you collect about, for example, your data, how they're doing in time, because you want to be careful to detect any large shifts in your data, because it can happen, with these systems that are alive, that are getting retrained on new data automatically. You want to be able to catch in time if your data suddenly changes, because even though you didn't change the model, you didn't touch the recommendation system, its performance can change because the inputs to the model changed very significantly, and you want to be able to catch that. That's why you have these this monitoring of the evaluation values and being able to see whether the newly trained models are performing similarly to the older ones, because that's what you would expect. Like, you wouldn't expect a major shift in a short amount of time. You also want to take a look at a longer scale. If your data is probably going to change on a longer scale, that's expected. That's something you have to count on. There is always something happening in the world, like different people are coming to your website during the holidays, different people come during work days, there might be some marketing campaigns or whatever. So there's going to be stuff happening all the time. Not a lot of times what's actually going on, but you should be able to detect these changes in the data and evaluate whether whether your model is able to handle them or not. Whereas, if it gets too much for your model, you might need to do some changes in how you process the data, and you might need to tune the model, which is like another reason when I go back all the way to the beginning, when I said that, you should expect this model to be something that or this whole system, something that you take care of, because it's not just implementing it and, letting it run in production. You will actually have to monitor it, and sometimes, even if you don't want to improve it, you will have to make some adjustments to the model because the underlying data changed, or the web's design changed, and suddenly the requirements changed. So you have to be able to react. Now, the last thing I would like to talk about is getting more and more important nowadays, and that's the ethical aspect of recommendation systems, because a lot of times now personalization is being talked about, the holy grail, everything should be personalized, we should be able to recommend everything. And yeah, sure, it helps when you recommend the right pants to the person that comes to your website, they're not going to be angry. But when you're recommending stuff like medication or some news articles about, I don't know, a lot of stuff that happens in the world, things get a bit more complicated, and there are definitely different expectations from models that work with, innocent things like, I don't know, fashion items, or some more serious things like, for example, the news articles. And basically, I would really like to appeal for you to stop and think what you're doing if you're asked to build a recommender system for these types of items, or when someone asks you to build a recommender system that recommends people, for any sort of activity. For example, there are these softwares for productivity measuring for companies, or for recommending people to tasks in companies, stuff like that. Be very careful when doing this, because you can very easily introduce some biases into the system. and cause like serious harm to, to people by recommending biased stuff. And actually, the European Union has prepared a regulation on this topic, and one of the many things that are mentioned there are that the artificial intelligence systems, which recommender system is definitely an artificial intelligence system according to the definition by the European Union. If these systems have a possibility of or capability to do harm to people, to citizens of the European Union, these are, high-risk systems. And in that case, even though they're not banned, like the regulation doesn't ban pretty much anything, but you might have to conform with some more stricter requirements on the system. Like you might need to be more transparent, like give users more information about what your system is doing. Why did you recommend them these items and not these ones? Give your users more power to change how the recommendation works, for example, and also allow for some auditing of your system to be able to see whether your system has like important biases or not. So I would really like appeal on you to be careful when building these kind of systems, because it can get tricky like very quickly and very easily. Yeah, I added some sources here just from the top of my head, and yeah, if you have any questions, don't hesitate to ask.
All right. Sorry. So let us thank Radek for the really nice talk first. And as he mentioned, now is the time for questions. If you're online, just type your questions into Zoom. We have colleagues watching the chat. And if you're here, I need to hand you the microphone.
On algorithmic side, I find really interesting the question of recomputing the, let's say, the collaborative filtering, the matrix factorization. What is the complexity of adding one item to the user matrix interaction and recomputing all the vectors? Are there some approximations for it?
Right. I don't know the complexity from my from top of my head, but basically you're not typically recomputing all the vectors. You just recompute one of them. Like typically when if a new item comes or a new user comes, that's more difficult. But typically the case of adding the interactions is that user that you already know of has done a new interaction with an item that you already know of. And in that case, you just recalculate the user's vector, which means that it's not, it's not as good now that the matrix factorization is not as good as it was before recalculating the vector, but it's, it takes the interaction into consideration. You're not doing the optimization like again fully.
But then at some point you recalculate completely, like fresh.
Yeah, exactly. I mean, even if you're doing this, basically you're doing this between the times when you recalculate on the data completely. So pretty much like all the systems, they are getting recalculated from all of the data every couple of hours. But some of these systems also take the new interactions that, came in these couple of hours into consideration somehow. Some of them better, some of them worse, right? For example, the matrix factorization is not perfect, is better than nothing. Some other systems, like if you have a simple k nearest neighbors, for example, this model trivially takes into consideration all the new interactions. You just add them to the matrix that, you're searching for the nearest neighbors. Or if you have like some autoencoder that creates embeddings of users and of items, like of course the dimensions cannot change if you have the autoencoder trained. But if you don't have a new user or a new item, even if you have a new user, if you have an autoencoder that encodes the item vector, like the interactions of items that has the dimension of the number of items in the system. So you take this vector of which items the user interacted with. You put it into your encoder, you get a vector representing your user. So you can do this for new users and their interactions. You can also do this for existing users with their new interactions. You just recompute their embedding. And basically you have trained your system in such a way where the embeddings that you get out of this encoder are in a space that allows you to either search for similar embeddings for the items or do a dot product with item embeddings to approximate the rating of this user item pair.
All right, thank you. So we have some online questions, right? All right, so from Václav, thanks for the talk. How specific the recommendation systems are? Would your system perform well, for example, in Zalando?
Oh, I mean, the system that I have described here, I guess. Yeah, this is like a general description applicable to recommender systems, like for anything, basically. If you have a recommender system that needs to scale to millions of items, and by items, I don't mean just products. I really mean like news articles, movies. It can be like Netflix, whatever. You know, it can be really anything. Like these are general rules that you can use if you want to build a recommender system for your website or any basically software that you want to use recommendations in. Like this fast ranker of everything, then slower, you know, more precise ranking, and then some additional optional re-ranking based on, you know, needs of where you are actually applying the personalization. This is like very general description that is applicable anywhere, basically.
All right, thank you. So are there any more questions here? Offline? All right.
I would be curious about the importance of interpretability. So you mentioned that it might be important with some law enforcement of making sure there are no biases and so on. I'm curious whether you have encountered like other maybe business related needs for interpretability, and thus, I don't know, some preference for like linear models and first order logic, or whether as long as A/B tests are better, it doesn't matter what the model looks like.
Yeah, that's a very good question. One of the things that I didn't get to mentioning because of the lack of time was that, yeah, the interpretability of the models is very important because, you know, I'm going to be honest, as soon as you build a recommendation system and it starts recommending something, you know, other people from the company are going to come to you and they're going to say, hey, I checked it out and I don't like it. Why is it recommending me this stuff? And, you know, it's good to have some answers, and it's good to be able to adjust based on the user feedback. So if your users tell you, hey, I'm getting a lot of these types of items, and usually the users don't describe their issues, you know, in a well-defined way. So you don't say, hey, I don't like this tech ID that is being, you know, a little bit too often shown in my feed. You know, they will say something like, you're showing me the items, they're a little bit too generic for me. You know, I would like something more specific. I would like something with a bit more, you know, more feisty, or I don't know, you know, like some of these like very non-specific descriptions of what the user expects. And like this is expected, right? Because the user doesn't care how the system actually works. They just tell you what they want the system to do. And you have to be able to work with that, which means you have to be able to find the literal definitions of the issues in your model. Meaning, if your model is interpretable, it really helps you a lot, because you can then take a look at the exact items that the user points out, because they will say, hey, I don't like this item and this item and this item and this item. And it's up to you to find the pattern. And if your model is not interpretable, it's kind of hard to find the pattern, right? Why is the model biased towards these specific items? So yeah.
All right. Are there any more questions? All right. All right, one more.
I was also wondering about the regression tests. Like,
right.
if you're redoing the retraining and changing the models, like you cannot expect really that everything stays exactly the same.
No. The regression testing is on some fixed data set. It's for your development needs. When you typically, what's going to happen is that you're going to build some models that perform, well. Then you find out that you want to add some other model into the pipeline, which takes some time. So you realize, oh, right now my pipeline is too slow. I need to speed things up a little bit, but I don't want to throw out any models. So I want to make them faster. So I want to optimize them a little bit. And this is exactly the case where you need the regression testing on a fixed data, where you basically check that the optimization that you've done in the code doesn't change the performance of the model at all. And that's like really happening a lot because, all these requests for new features, they keep coming, right? You keep adding stuff, but at the same time, you can't afford to get slower. But you want the model to do more stuff, but at the same speed. So you need to change something, right? So it's good to have tests that allow you to iterate quickly on these optimizations. Yeah.
All right. Do you have some more questions? I have one more myself. So you mentioned the difference between offline and online evaluations, right? Do you have some tricks for making the offline evaluations closer to the online?
Yeah, I mean, one of the tricks is to show random recommendations on your website to users on hopefully a portion of the traffic. And then you gather the data from these random recommendations, and you can use this data of which users clicked on what when they were shown random items to produce unbiased estimates of click-through rate during offline evaluation. If you see where I'm going with this, like if you collect this data, you create a data set with randomly shown items to users, then you have this like unbiased estimate of what the users are clicking on because you didn't have the bias of the previous recommender system there, which usually is always there. You always rank your items somehow, not randomly, right? And this bias is the issue because if you do offline evaluation on data set that is biased somehow, then the result of the offline evaluation is biased as well, right? So yeah, that's a good trick. Of course, it costs money because showing random recommendations to users is costly and they're not going to like it. And you have to collect quite a lot of data because you need the users to actually click on something, which is quite hard if you have millions of items and you're showing random ones.
All right, thank you. So yeah, one more.
Yeah, actually, this is related to Tonda's question. Like I didn't, or I have no education in this area, but my gut feeling tells me that I lacked in the talk that classical exploration versus exploitation trade-off, and that perhaps like it's a gut feeling. I would say that random samples seems like too much exploration, and that maybe some compromise between random and optimal would give you more, perhaps hopefully more valuable data. But also in the online setting, you don't put some randomness into the recommendations in let's say in GLAMI.
Yeah, that's getting a bit too close, but to my heart, but definitely it's very valid question. Of course, there is exploration exploitation trade-off. It's actually kind of shown in these metrics that you look at in the offline evaluation. Coverage is exploration. Coverage is just a ratio of all the items that you've recommended. Basically, how many items have you recommended out of all of your items? So if you have a recommender model that just recommends the best sellers, it has very low coverage, right? Because it shows the same items to all the users. If you have a system that is personalized and shows different items to every user, then this system will have a bigger coverage because it shows more different items. And then you have this recall that basically says how many relevant items have I shown to the user in top like 10 positions, let's say. And this is like the exploitation, right? Because I know that users are going to click on some things, so I can show these items to them every single time. But I'm not sure, right, with the other items, I want to be able to show to these users some diversity. And this is like really a thread through a bunch of papers that, you know, adding diversity helps. Like, yes, it helps, you know, having more diverse recommendations helps. And yeah. So
I mean, what exactly is that coverage?
Coverage, it's a ratio of all the items that you recommend. If you give me 100 users and you ask me to recommend 10 items to every one of these users, then I create a set of all these 10 recommended items together, and I take the size of this set and I divide it by the number of all the items. I get the ratio. Yeah, I mean, you might, yeah, exactly. Yeah, exactly. So if all the users will get the exact same items, the coverage will be low. If all the users will get completely different items, the coverage will be higher. So there is more like diversity in the system as a whole, but then there is diversity in the recommendations to the user, you know, himself. So you also want to show to the specific user different things over time. So that's, you know, another aspect of the diversity. You can show different users different items, but you also want to show different items to the same user.
All right. So I think we're pushed by the time a little bit. Or all right, one more question.
Yeah, we've got 4 minutes still, so plenty of time.
Last question maybe about the ethical aspects. What is your personal opinion? Is there any kind of area or segment where this kind of recommendation should be definitely banned or highly controlled by government? For example, portals with job offers or something like that.
Yeah. Yes, I definitely have strong opinions on that, and I'm glad to share them with beer in my hand, I guess. But I am definitely a proponent of stronger regulation in this area, because I feel like hoping that the technological companies will solve all the issues with the users, you know, health in mind. I'm not exactly convinced. So I welcome this regulation from the European Union. I actually think it's very well written. You know, a lot of people hate it. And yeah, I'd like to meet them and discuss it with them.
All right. I think with that, we should thank Radek again. And then there's a little bit of organization. We don't have the topic or date of the next Miton Times yet. So watch meetup.com where we will announce it as usually. And thank you all for coming, both offline and online. We're looking forward to seeing you next time.
Thanks.